So now in this video, what we want to do is, using these properties, how do we expand the log? Meaning, how do we go in one single log to make it into expanded form using these properties itself? And like I said in the last video, usually we're going to be using 3 to 6 to help you out when expanding the log and condensing it. We'll talk about that a little bit as well. Okay? So first thing is we want to expand the log in H1. So essentially this entire thing is being evaluated in the log. Okay? Now when it comes to expanding logs, I always like to give you guys a little template when it comes to it. The best way I always thought when it came to expanding logs is using this little template. Okay, so for expanding, what you kind of want to do is, first thing you want to do is get rid of all the division. So any divisions, meaning you're going to use this portion, right? Break it up using the subtraction rule. Okay. So after you have all the divisions broken down, next thing you want to do is do the multiplication one. You want to break down all the multiplications. So in other words, you're doing property 4. So essentially, it's property 5 first, then property 4, and then finally, what you want to do for each individual log is property 6. Okay. So then what you want to do is each one, you're going to do property 6 to break it down. And that's going to be kind of the template how you want to do it when it comes to it. And you're going to see in these examples that's how it's going to be done. Okay. So using this template, looking at number part A over here, guess what we're going to do? We're going to look at the division first. So it's right here, x to the third divided by 7 over x. So this becomes now log of x to the third minus log of 7 plus x. Okay. So now we got everything's division, right? There's no division individually. So now what we do is, well, are we multiplying inside the logs? So we're not multiplying anything, right? It's just x to the third. And this is a trick question, right? It's addition, so not technically multiplying, so I can't break that up, right? There's no additions on the inside breaking up, right? It's just either multiplication or division. It's one or the other. That's it. Okay. So we're done there. So step 2 is actually done already, right? But there's no step 2 for multiplication. So now we do step 3 is, for each one, we're doing the exponential rule. So in other words, are there any exponentials we can get rid of to put it in front of the log? Okay. And we actually do right here. Okay. So using rule 6, what we do is going to bring it to the front. So it'll be 3 times log of base 10 of x of just single x minus log of x, or 7 plus x. And there we go. That's broken down completely, okay, when it comes to it. Now, if you're wondering, why is there no base in the log? When it comes to log base 10, another way we rewrite this is just log with no base. So if you do not see a base, if it's missing a base, always assume it's log base 10 no matter what. It just, it's a universal symbol. We always use log base 10, so it's just a universal. Even in your calculator you see there's no base, it just says log. So if you do not see a base on here, always assume it's log base 10. Okay. All right, so let's keep going. So let's try B now, right, when it comes to it here. Okay. So B has it is, well, we want log of y to the 4th times y squared plus 2. Now notice in this one, right, we do not have any, get a little closer. Yeah. So we do not have any divisions. So step 1 is done. So now we go to step 2. And step 2 is multiplication. And we do, right? It's this times all of that. So when we write this, it's going to be log of y to the 4th, because we're multiplying the addition, plus log of y squared plus 2. Or sorry, well, plus 1. Okay, so now we're going to have that. Now we go back to individually and go to number 6, right? Exponential first. Now, again, like the last one, we do have an exponential here, right? So we can do that there. So it'll be 4 times log of y plus, now here's a trick question. Yes, we do have an exponential there. However, remember, the exponential has to be applied to the entire thing, not the individual ones, because again, we cannot break up the addition. So because it's actually a true question, this is actually your answer. You cannot break it up itself. It's a really big trick question based on the log properties itself. Okay. All right, so why don't you guys try C? So I'll give you a quick pause. So 3, 2, 1, try, and then we'll do it together. All right, so hopefully you guys try this one. This is a pretty hard one because there's a lot of information happening here. Right, so first off, we have to do division. So we're going to have log of radical x plus 1 minus all of this at the bottom. Okay. All right, so now that we have that done, now we do multiplication, right? There's step 2. So we're not multiplying anything here, so that stays the same. But we are here, correct? Multiplying this times all of that. So if we expand this log, it's going to be minus. Now, in parentheses, remember, this we're just breaking this part apart. So this minus still is applied in the inside. So it's going to be log of x squared plus log of x plus 1 to the 5th power. Okay. And then finally, we have to do the exponential rule. Now, this is a trick question. Remember, another way to write your radicals into exponentials looks like this. So x to the 1/2 is the same thing as radical x. Right? So if I rewrite this, so that's technically 1/2 power, so it'd be 1/2 log of x plus 1 minus, and if you really want, you can bring this inside, be minus 2 times log of x, because you can bring that 2 in the front, and then right minus, and this 5 can also go in the front, log of x plus 1. And there you go. That's the entire expanded form of part C. Sometimes it can get pretty complicated, right, when it comes to, as long as you follow those 3 steps, it's not that bad as in, you know, a little bit of exponential rules when it comes to it. Okay. So that's expanding logs. Okay. Now what we want to do is, well, what if I give you the answer, right? If I give you the expanded form, how do you, come up with what I gave you before? And that's called condensing the log. So, when it comes to right as a single log itself, okay? Now, believe it or not, when it comes to going the opposite direction, meaning condensing, you're literally going to go into the opposite order. That's it. Believe it or not. So when it comes to condensing, meaning bring everything together, is we're going to go here, here, and here. When it comes to expanding, you go there, there, there. Just go up the ladder when it comes to condensing, come down the ladder when it comes to expanding, okay? So let's do an example so you can see how this is going to be out here. So if we talk about this, right, go the complete opposite order, meaning each individual one, we're doing step 6. Now, sometimes going opposite is a little tricky going, forwards. You got to think backwards, right? So in other words, remember, they're going to give us this, and we want to write it like that itself. So since we have any number in front of the log, automatically pops it up to the power itself. So if you notice, right, this 3 is being multiplied by the log, so therefore, this is our value should be popped into there if I did that rule. So if I rewrite this now, this is going to be log base a of x to the 3rd power plus log base a of 7. Okay. So now, again, right, because we have addition, so addition corresponds to multiplication. Right now we're going the opposite order, right? I give you this, we want to go backwards. So because it's adding, I now multiply them together when it comes to it. So because of addition, it'd be log base a of x to the 3rd times 7. And you can just leave it like that in parentheses. And that's in a single log itself. Okay. All right, so let's try B, give you more practice. So I'll give you the hint, right? Any number in front of natural log or log, remember, natural log is just log base e, right? Remember, it's just a shortcut, as we talked about last time. So it does the same properties no matter what you actually see. Okay, so therefore this now becomes natural log of x to the 2/7 power minus natural log of 8 minus x. Okay, so since we're subtracting, right? Therefore subtraction, the opposite, it would be to divide the logs. And the order does matter, right? It's always top minus bottom when it comes to this portion. So when we can put them together, it's going to be natural log of the top, which is x to the 2/7, divided by 8 minus x. Again, all in one log itself. In this case, the natural log. Okay. All right, so once you guys try C. C is, again, a little bit difficult, but just go ahead and try it out. 3, 2, 1, pause. Okay, so hopefully you guys try it, see if we can correspond to this. Now, again, right, give you guys a hint. Here's a negative, so therefore this is going to be natural log of x to the minus 3 power plus 7. Oh, That's it. So natural log of 9 to the 7th power, and you can leave it just like that, plus natural log of x minus natural log of x minus 2. Okay, so we have a lot of pluses and a minuses, right? So the question is, what do we do first? Good news is, we always do as order operations from left to right. So as we read from left to right, what comes first is how we do it. So multiplication, right? We see multiplication first, so that's what we do first. So there's going to be plus, so if it's easier, just break two it apart. So plus means multiplying, so natural log of x to the minus 3 times 9 to the 7th. And you just rewrite this if you're not sure, right? Always just do two logs or natural logs to help yourself out. Okay. All right, so this is all 1. So plus again, so I'm going to put this together with another multiplication. So it'll be now natural log of x to the minus 3 times 9 to the 7th times x, then minus natural log of x minus 2. Okay. And then finally, subtraction becomes a division. So now all this log becomes x to the minus 3 times 9 to the 7th x all over x minus 2, like that. And if you want, you can simplify, right? When you come to this, you can have natural log of x to the minus 2 times y to the 7th over x minus 2, right? Simplifying the x and the 3's. You can bring this to the bottom, whatever you prefer. But, as long as you get there, I'm happy when it comes to it. Okay. All right, so that's finishing this section. It's a quick, short section, logarithmic functions, and things like that.